Welcome back. In the previous video, you would have seen how to train this model. Now that the model has been trained, the next step is to prepare it for the deployment on the microcontroller. So Keras model is too large or it includes like training only components. But we need lightweight format called the TensorFlow Lite. So the TensorFlow Lite keeps only the parts needed for the inference, the architecture and the trained weights, and discards everything else. We convert this with this one line called a TFLite converter from Keras model, and we'll put our model or the file in this places. So the result is .10 TFLite file that only a few kilobytes in size, very small enough to fit in a microcontroller memory, and keeps only the model architecture and weights. So why exactly do we need this conversion? Let's see. Again, why we are converting to TFLite file? Microcontrollers like Arduino Nano BLE sense have very strict memory and storage limits, just a few hundred kilobytes of RAM. So the TensorFlow solves this by shrinking this model size and optimizing it for speed. It removes training only features and supports quantization like int8 and float16, and makes models run faster with less power. So without conversion, the model simply won't run on the hardware. So it enables true embedded AI inference. Here you can see the code. Here I am saying this model, Keras model, and converting into TensorFlow. And this is the step we can see. We are comparing the file sizes. Some huge MBs of file will be converted into just KBs of file. This is a step to bridge between the Python world and the embedded world. Once we have the TensorFlow Lite file, we'll need it embedded into our Arduino projects. For that, we have to turn this into a C array. We'll see that in the next slide. Arduino board doesn't have a file system, so we can't just copy this model which we created, model.tflite, into a memory like a PC. So instead we use this XSD tool to convert it into C array or a C file. So the command here we are using it is !XSD-I model which we created, and the model the name we are going to turn to .cc file. So we are running this command and it generates this C format. This can be included via include.h. We will see further. And it's copied into flash memory during the firmware upload. So this byte array is compiled into a firmware and compiled. At the runtime, TensorFlow Lite micro can actually read it directly. Think it as embedding the model into the program itself or the Arduino itself. So now that model C is formed, we need interpreter on a device to run it. TFLite micro interpreter setup. This TensorFlow Lite micro is a stripped down interpreter designed for especially these embedded systems. So it doesn't need any OS or dynamic memory. And it's perfect for tiny microcontrollers. This setups include TFLite micro headers and all ops resolver to register required layers and create a static arena, RAM buffer, and include the model with the get model. Use a micro interpreter to run inference. So this environment ensures our sine wave model can actually run on a hardware. This brings us to the end of the chapter 4. We've seen the entire journey from data to the deployment. So key takeaways from the chapter 4. So let's recap. We built a regression model from scratch in a Keras, used a TensorFlow to train and evaluate it, converted it to TensorFlow and then C array, deployed it on an Arduino Nano BLE cells. Like we'll deploy it in an Arduino Nano BLE cells. This is a complete TinyML workflow. Build, train, convert, deploy and run it. So it's a huge milestone. You just run a on a microcontroller, you will just check it in a PC once, so it's running or not, and then converting it, and then we are going to deploy it in a microcontroller. But building a model alone is not enough. Let's talk about applications. Yes, the applications. In further videos, we'll see how our sine wave model is applied. Like we'll use it in a LED blinking in the microcontroller. So stick with this course. Thank you.